Today we're going to go over section 7.2. In this section, we're still going to be using the law of sines. Today we're just going to go over triangles that have ambiguous cases, and we're going to go over what that means in some of the examples today. So today we're going to be able to identify if there are ambiguous cases while using the law of sines. So why don't you go ahead and do example 1, attempt that problem, and then once you get your answer, press play and then check it. Alright, so if you would have started this one, you should have drawn your triangle ABC. And we knew the side length A was 2, the side length of B was 6, and A was 30 degrees. So when we set that up, we would have had the sine of 30 degrees over 2 equals the sine of B, the sine of B all over 6. So to get sine of B by itself, we're going to multiply both sides by 6. And we'll get 6 sine of 30 over 2 equals the sine of B. And then to get just B, we're going to take the inverse sine of both sides. And we usually don't show it on the side, but this is technically what we're doing to that side. And when you take the inverse sine of sine, you're just left with B. So normally we don't show that step, and it's okay if you don't, but that's what we are doing to both sides of this equation. So then this is where we would want to go to our calculators. So let me pull up my calculator. There it is. So we're going to do the inverse sine of 6 times the sine of 30 divided by 2. And you'll notice when we do this, we are going to get a domain error. And the reason is because this would be taking the inverse sine of, let's do an enter, let's get rid of this. If we do 6 sine of 30 divided by 2, this is taking the inverse sine of 1.5. And we know we can't take the inverse sine of a number that's greater than 1 or less than -1. So this one would make no triangles. Yesterday, what we went over, there was always one triangle that showed up for each of our answers. Today, some of the examples are going to have no triangles that are possible because the side lengths aren't going to be long enough to form a triangle. Okay. Next, we're going to go over ambiguous cases. So an ambiguous case is when we can form two triangles with the information they give us. So in this one, if they gave us the measurement of angle A and the side length next to it, we could have a few different triangles, even with this leg length being the same measurement. So it could form this triangle on the outside, where the measurement of angle A and X and Y are all the same as this triangle that is smaller, with A, X, and Y all being the same measurements. So this is what an ambiguous case is. We're going to get information where there's going to be possibly two different triangles that can be formed. And it is important that from this point forward, you check every triangle to see if there's an ambiguous case. Because if you forget to do that on a quiz or a test, that could be half the points for a question that you're missing out on because you didn't do that. Alright, so let's go over an example. Example 2, we're going to find the missing parts in triangle ABC if A equals 54, B equals 62, and A equals 40. So I'm just going to draw a sketch so we have a visual to look at. And then we can fill in the information they give us. And we know A is 54, B is 62, and A is 40 degrees. So let's go ahead and solve for angle B, because that's what the information we have that we're able to solve for. So we'll do the sine of 40 over 54 equals the sine of B over 62. We'll go ahead and multiply both sides by 62. That simplifies. And then we would end up taking the inverse sine of both sides to get what B equals. So we'll do the inverse sine of this, and that will tell us what B equals. So I'm going to just go ahead and type that into my calculator. 62 sine of 40 divided by 54. And when we're working with degrees, you can just go ahead and round your answer to the nearest degree. So for this one, 47.56, I'm just going to round that up to about 48 degrees for B. Now, after we find this first angle, this is when we are going to check to see if there's an ambiguous case in this triangle. So we know that the sine is going to be a positive value, and we could do that by typing in 62 sine of... Oh, actually we know it's going to be a positive value because it's going to be an angle in a triangle. So those have to be positive angles. So B is going to be positive angle in both quadrant 1 and 2 because we're taking the sine of that value. So we know that we could have an angle in quadrant 1 that's 48 degrees, or we can have an angle in quadrant 2 that has a reference angle of 48 degrees. So to find the actual angle, we would just take 180 minus 48. And that tells us that this whole angle is 132. So in our first triangle, we can say that angle B is equal to 48 degrees. In our second triangle, we can say B equals 132 degrees. And we know that all three angles in a triangle have to add up to 180 degrees. So we would want to make sure that these angles work with the triangle that we are given. So if we're looking at our first triangle right now, this one we know that B equals 48, and we had A equals 40. That leaves plenty of room for us to still have our third angle, which is going to be 92 degrees. So we know that C is equal to 92 degrees. Then we're going to go ahead and we're going to check to make sure that it works in our second triangle. We know A was 40 degrees. And now we can see if there's enough room for this one to actually form a triangle. So this one would be 8 degrees. So now we know that there is two triangles, or there are two triangles that can be formed with the given information that they gave us. And then the last part we would need to do is find the last side length in both of these triangles with the information that is given to us. So why don't you pause it and try to find side length C in triangle 1 and in triangle 2. And then once you have your answers, you can press play to see if you got it correct. Okay, in our first triangle, finding C, we would do the sine of 40 over 54. And I do recommend using the information where we didn't have to round any of our answers. So we rounded our angle for B, so we're going to use the sine of 40 angle A because that one is an exact answer that we know for sure. And in this one, we know C is 92 degrees, so we can do the sine of 92 all over side C. And from yesterday, if you rearrange this equation, you would end up with C equals 54 sine 92 all over the sine of 40. And you can just go ahead and type that into your calculator. Divided by the sine of 40. And we would get about 83.95. So if we rounded that one, it would be about 84.0 if we rounded it to the first decimal point. Okay, so that is all of our answers for the first triangle. Then we can go ahead and do the same thing for our second triangle. We're still going to use the sine of 40 over 54. And this time, our C angle was 8 degrees. So we can do the sine of 8 degrees all over C. And if you cross multiply and rearrange your equation, for this one, you're going to get C equals 54 sine of 8 all over the sine of 40 degrees. And again, we would type that into our calculator. And this one we would get about 11.7 for the length. And the book might round a little bit different, but we should round to at least 1 decimal point for side lengths, and then you can round to the wholest degree for the angles unless it tells us to do otherwise. So in this one, it has 2 possible triangles. And if you look at your book on page 342, it does show you what both triangles would look like. One is a little bit bigger like this. And then the second one has a shorter side, and then it's a lot more narrow with the information they give us. But both of these triangles are possible. And you can see how we have a lot more answers than we did yesterday. So anytime there's an ambiguous case, you will need to solve for both triangles to get full credit for that problem. All right. So then let's look at example 3. This one says find the missing parts of triangle ABC if C equals 35.4 degrees. A equals 205 feet and C equals 314. So we're going to draw our picture and fill in the given information. And we know that C is 35.4, A is 205 feet, and C is 314 feet. And we're going to find our missing parts. So the first thing we're going to do is we're going to look for angle A because that's across from one of the given sides that we have. So then we would do the sine of 35.4 all over 314 equals the sine of A over 205. And to get sine of A by itself, we would just multiply both sides by 205. And to get A, we're just going to take the inverse sine of both. So then we would end up with what A is equal to. So if we go ahead and type that into our calculators, we will get our reference angle, and we can see if we're going to have one or two triangles here. And we got about 22.2, so we can just round this to the nearest degree again, about 22 degrees. Now we're going to go ahead and check, do we have one or two triangles here? It might be helpful if you do draw a second triangle. A, B, and C. And I'm still going to fill in the information that we know for sure. Alright, so we know in our first triangle, A is going to be 22 degrees. And these angles are both small enough in our first triangle to have a third angle. So we have 180 minus 22 minus 35.4. So our third angle is going to be about 122.6 degrees. Okay. So then we know our first triangle for sure makes a triangle. And the last thing we would need to do is find the side length B. And we could go ahead and do that now if you want. And we would just use the law of sines just like we have been before. And again, I recommend using the two sides that you are given. So we were given the angle C and the length of side C. So I recommend using those values when finding your missing part, just because your answer will be a little bit more accurate. Oops, I forgot sine over here. Sine of 122.6. So then I'm just going to multiply both sides by the sine of 122.6. And that will tell us what B is about equal to. 314 times the sine of 122.6, all divided by the sine of 35.4. And we do get about 456.7 in our first triangle. Now we can go ahead and solve for our second triangle. So in our second triangle, we know that we have a reference angle of 22 for angle A. But we're going to find our other positive angle. So we know it has a reference angle of 22 degrees. And if we take 180 minus 22, we would get 158. So we know our second angle that's possible for angle A is 158. And then to find angle B, we would just subtract our two known angles from 180. So 180 minus 158 minus 35.4. And you'll notice we get a negative angle, negative 13.4. Which we know that's not possible in a triangle to have a negative angle length. So this one, we only have one possible triangle. So looking over what we've covered today, we know that we could possibly have no triangles with the given information. We could have two triangles like there were in example 2. Or we could have one triangle like example 3 showed. So these are kind of the steps that you would need to be able to take in order to solve a triangle using law of sines. So why don't you go ahead and do the homework for today. It is 7.2, page 344. It's numbers 1 through 9, the odd numbers, and then 17, 19, and 23. We still will have a quiz tomorrow. on 7.1 to 7.2. We will have time at the beginning of a class to answer any questions that you might have on today's homework or yesterday's homework. So before you take the quiz, we will get questions answered. And then it'll be a very short quiz, so you will have plenty of time to finish it still in class. All right, have a great day, and I will see you tomorrow.